called the dead reckoning technique. Let's assume that we're sailing from A to B, and that A is the last fixed position plotted on the chart at 10 o'clock. Now it's 11:30, and we have to plot a new position using the dead reckoning, dr. The true course is 0:45 degrees, and the speed through the water, taken from the speed log, is 7 knots. Knowing the course, the speed, and the running time from 10 a.m. to 11:30 a.m., we can find the distance sailed using the formula d is equal to s times t divided by 60, where d is the distance in nautical miles, s is the boat speed, and t is the time in minutes. In our case, 7 knots times 90 minutes divided by 60 equals 10.5 nautical miles. Using the dividers, we span a distance of 10.5 miles on the latitude scale, which is closest to the course line and which runs along the sides of the chart. To work out the set, direction, and the drift, speed, of the tide, we refer to the tidal diamonds on the nautical chart or to the tidal stream atlas. Let's assume that at that time the set is 110 degrees, which means that the direction of the tide is towards 110 degrees and the drift is 3 knots. To apply the set, direction of the tide on the 11:30 dead reckoning dr position, we place the parallel ruler on the 110-degree line of the compass rose and transfer that line to the dr position. To apply the drift, speed of the tide on the 11:30 dead reckoning dr position to our time frame, we use the formula d is equal to s times t divided by 60, where d is the distance in nautical miles, s is the tide speed, and t is the time in minutes. In our case, 3 knots times 90 minutes divided by 60 equals 4.5 nautical miles. Using the dividers, we span a distance of 4.5 miles on the latitude scale which is closest to the course line and which runs along the sides of the chart. We apply this span, placing one leg of the dividers on the 11:30 dr position and the other leg on the 110 degrees tide set, marking the new position with a triangle, recording the time as 11:30. This is our 11:30 estimated position, EP. Using the parallel ruler, we transfer the 0:45 degrees course to the new 11:30 estimated position, and from there we continue to plot our new positions as we progress on our route. Plot a running fixed position. Assuming the course is 0:80 degrees and the speed is 8 knots or 8 nautical miles per hour, we take a bearing of 0:45 degrees on Alpha Rock at 0900. Now convert the compass bearings to true bearings and we plot it on the chart. After 30 minutes we take a new bearing on the same rock that reads 0:15 degrees. Now convert the compass bearings to true bearings and plot it on the chart along with the new time, 0930. Knowing the speed, the next step is to determine the distance that the vessel sailed from 0900 to 0930. For that we use the formula d is equal to s times t divided by 60, where d is the distance in nautical miles, s is the boat speed, and t is the time in minutes. In our case, 8 knots times 30 minutes divided by 60 equals 4 nautical miles. Using the dividers, we span a distance of 4 miles on the latitude scale, which is closest to the course line and which runs along the sides of the chart. We applied this span on our course, placing one leg of the dividers on the 0900 LOP intercepting the course and the other leg on the course line. Using the parallel ruler, we transfer the 0900 LOP to the blue mark. As we notice, the two LOPs intercept at the point RF. This is our running fix position. By doubling the angle on the bow, having in mind the properties of an isosceles triangle. This fix requires the first bearing to be less than 45 degrees from the bow. Assuming the course is 0-90 degrees and the speed is 10 knots or 10 nautical miles per hour, we take a bearing of 0-60 degrees of the Charlie radio tower at 0-900 or 30 degrees from the bow. Now convert the compass bearings to true bearings and plot it on the chart. We observe the Charlie radio tower, and when the new bearing reads 0-30 degrees or 60 degrees from the bow, we note the time 09:15. Now convert the compass bearings to true bearings and plot it on the chart. Knowing the speed, 10 knots, and the elapsed time between the two bearings, 15 minutes, we use the formula D is equal to S times T divided by 60 to calculate the sailing distance between the two bearings. In our case, that's 2.5 nautical miles per hour. As we can see, the two bearings and the course form an isosceles triangle, ABC, where sides C and B are equal. That means that the distance from the Charlie radio tower, when we took the second bearing at 09:15, was 2.5 nautical miles. Using this method, we have a bearing and a distance using only one object. The bearing from lighthouse A, place the parallel ruler on the compass rose at the 0:45 degree line and transfer that line passing from lighthouse A and crossing the course line. Then the bearing from lighthouse B, place the parallel ruler on the compass rose on the 0-90 degree line and transfer that line passing from lighthouse B and crossing the course line. Thirdly, the bearing from island C. Place the parallel ruler on the compass rose on the 135 degree line and transfer that line passing from island C and crossing the course line. Generally, when using 3 LOPs, and due to small errors in the bearings, a triangle may form where they intercept. In this case, the center of the triangle will be the fixed position.